Yes, you're welcome to today's math class. Looking at this nice integral question, we are going to be using substitution rule to solve this. So how do we go about this now? So let's start. We have the integral of, don't forget, cotangent of s is the same as saying 1 over root tan x, right? So let's substitute that. We have root tan x plus 1 over root tan s, close bracket ds. Now, when you solve this fraction, the denominator rather is root tan s, right? And at the numerator, when we have root tan s multiplied by root tan s, is going to give us tan s. And here we have 1 ds. So now, the substitution we are going to be making is that let u equals u squared equals tan x. So when u squared is equal to tan s, when you take the derivative of both sides, that is du ds, right? We have 2u du to be equals to, the derivative of tan s is sec x, sec square x rather, ds. Now dividing, don't forget, from this we know that, from our trigonometric identities, we know that 1 plus tan square x is equals to sec square x, right? So we are going to be making this substitution. So dividing both sides by sec square x, we have 2u du divided by 1 plus tan square x to be equals to dx. Now, knowing that u squared is equal to tan x, so when you square both sides, we are going to have u raised to power of 4 to be equals to tan square x. So now, substitute this here. When you substitute this here, we have the s to be equals to 2u du divided by 1 plus u raised to the power of 4. Now let's move back to this. So we have the integral of, don't forget, tan s is equals to u squared, right? So we have u squared plus 1 divided by root of u raised to the power of 2 is going to give us u, right? And we have the s to be multiplied by 2u du over 1 plus u raised to the power of 4. So you can cancel out each other here. Factor out these two. So we have to the integral of u squared plus 1 over 1 plus u raised to the power of 4 du. Now, dividing numerator and denominator by u squared. So we have to the integral of u squared divided by u squared is going to give us 1. 1 divided by u squared is going to give us 1 over u raised to the power of 2, which is u squared. So here now 1 divided by u squared is going to give us 1 over u squared. And u raised to the power of 4 divided by u squared is going to give us u squared. So don't forget the u. So let's add minus 2 plus 2 at the denominator. Now recalling this algebra property, when you have u, for instance, when you have u minus a squared, this is equals to a squared plus u squared minus 2 multiplied by a and u, right? Now, using this property, this algebra property at the denominator here, for this, you can definitely say that this is equals to u squared minus 1 over u minus 1 over u, right? So we have to the integral of 1 plus 1 over u squared at the numerator, and denominator, after simplifying this, don't forget we have u minus 1 over u squared plus, so we can write 2 as root 2 raised to the power of 2 du. Now opening to the next page, I'm going to be making another substitution. Let t equals u minus 1 over u. So when you take the derivative of both sides, here you are going to have dt to be equals to 1 minus, so when you differentiate 1 over u, this should give us plus 1 over u squared. So don't forget the symbol du. Now if you look closely now, we can just substitute this here, right? Now, making the substitution back to the question, we have the integral. So here now, 1 plus 1 over u squared multiplied by du is equals to dt, right? So we have dt over, here now we have t squared plus root 2 all squared. Now, we'll be making this substitution standard integral formula where you have the integral of dx over s squared plus a squared. This is equals to 1 over a tan inverse x over a plus c plus our constant, right? Now, let's make this substitution now. So we are going to have 2 multiplied by open bracket. So we have 1 over a here, which is root 2. So 1 over root 2 tan inverse x over root 2 plus our constant, which is c. So when you open the bracket, we have 2 over root 2 tan inverse x over root 2. Sorry for my bad. It's t, not s. So root 2 plus c. But from the option, the answer is not left in this form. So we are going to rewrite this. When you rationalize this, this is equals to root 2. And don't forget, the other time we said t to be equal to 1 minus 1 over u. And don't forget, when we started rather, we said u squared is equal to tan s, which means that u is equal to root tan x, right? When you now substitute this here, we are going to have t to be equal to root tan x minus 1 over root tan s. And don't forget, 1 over root tan s is going to give us cotangent, right? This is equal to cotangent. So when you now substitute back, we are going to have root 2 tan inverse open bracket, whereby t is equal to root tan s minus cotangent x, right? All divided by root 2 plus our constant, which is c. Guys, this is our final answer. Please don't forget to like, share, and subscribe to my channel. Thank you. Bye bye.